to see what the problem is asking you. So now that we're done with those, let's move on to polygons. These are kind of challenging, so make sure you study when you read the rules. So page 460 to 462, read and try problems 3, 6, and 8. All right, so let's look at our problems. We have problems 3, 6, and 8 that I asked you to go over, but first I want to do number 1 because there's a formula that you need to know as well for interior angles. So the first one, it says the measure of an interior angle, find the measure of an interior angle of a regular pentagon. A pentagon has 5 sides, so let's write that up here, 5 sides. And let's learn the formula. To find the measure of all the interior angles, we have a formula that states 180 times n minus 2 will give you the sum of all the interior angles, n being the number of sides. So let's take 180, insert how many sides, which is 5, and subtract it from 2. So we have 180 times 3. 180 times 3 will equal 540. And that's the sum of the interior angles. The problem wants to know the measure of one of the interior angles. So knowing that we have 5 sides, you can take 540 and divide it by 5, and you get 108. So that's the measure of one interior angle within a pentagon. So that would be selection D on number 1. Moving on to number 3, the easy thing about exterior angles is all exterior angles of any regular polygon is going to equal 360. So, reading through the problem, find the sum of the measures of the exterior angles of a regular triangle. All you need to know is that all the sums of any exterior angles equals 360, and you'll know that selection E is your answer. So, let's move on to number 6, where it gets a little bit harder. Number 6 asks you to find the area of a regular hexagon with sides of 4 centimeters. So let's write out hexagon. Hexa means 6. So we have 6 sides. So let's draw our picture. And we know that one side is 4 centimeters. Okay? So the radius, you need to draw it in. And you can draw, the radius is always going to equal the side, a measure of the side. Okay? Then you can make yourself a right triangle by making a perpendicular line from the radius to the base, cutting the base in half. So we know that this side would equal 2 centimeters. So to find the area of this hexagon, we know that the equation is 1/2 apothem times perimeter. Okay, perimeter is just the sum of all sides, so you'll do 4 times 6, and that equals 24. So we know that the perimeter is 24. Anytime they ask for perimeter, just add up the sides, the measure of all the sides, and that will give you your perimeter. Now we need to find the apothem, which is right here. And to find the apothem, we have to utilize the Pythagorean Theorem, which we only use for right triangles, and it states that the legs of the triangle A squared and B squared equals C squared. A and B is the legs, which here on your triangle, if you look at your right angle, whatever's connected to your right angle is the legs, and opposite of the right angle is your hypotenuse. So knowing this, let's plug in our formula and we can find A. So we have A squared plus B squared, which is your other leg, equals your hypotenuse, which is 4 squared. Let's solve for A. So you have A squared plus 2 squared is 4 equals 4 squared, which is 16. So now we need to bring our 4 and get it to the right side. So we have to subtract 4 from both sides. A squared equals 16 minus 4, which is 12. To get A by itself, since it's squared, you have to take the square root of both sides, which leaves A by itself and the square root of 12. Now, this isn't in its simplest form, so you have to reduce it. Inside of your square root, 12 equals 4 times 3. which we know 4 is a square, a perfect square. So the square root of 4 is 2, and inside your square root you have 3. So this would be your apothem. Apothem equals 2 square roots of 3. Now we have everything to plug into our formula to find the area of our hexagon. So let's plug it in. The area equals 1/2 the apothem, which is 2 square roots of 3, times our parameter, which is 24. We already figured that out. It's just the sum of all the sides. So it's 24. Okay? Here, if you have 2 times the 2 square root of 3, the 2's will cancel out, leaving you at the square root of 3. So 24 times the square root of 3 is simply 24 square roots of 3, and that equals your area. Okay? So your answer would be C, 24 square roots of 3, and make sure you write in your measurements as centimeters squared since it's the area. So big thing, this is a big, huge problem, but just to know, parameter is the sum of all the sides. Area is 1/2 apothem times parameter. And to find the apothem, you have to utilize your Pythagorean Theorem, which states that the legs of the triangle equals the hypotenuse. So at any point, you can find each side of a right triangle. So let's move on to number 8. And this one should be a little bit simpler. Okay, number 8 says the perimeter of a regular heptagon is 36.4 centimeters. So a regular heptagon, hepta, means 7, or 7 sides. And it says that the perimeter equals 36.4. Now remember, perimeter is just the sum of all the sides, which each side is equal to each other. So all you have to do is take 36.4 and divide it by 7, and you would get the measurement, the length of each side, which is what it's asking for. So 36.4 divided by 7 is 5.2 centimeters. So each side of the heptagon is 5.2 centimeters. So knowing what parameter and area and all of those terminologies is, it will help you out with the problem. So make sure and study and drill those into your brain. So now that we're done with the regular polygons, let's